Hello, hello, everyone. Welcome to the workshop. Great to see people signing in. We're going to wait till 9:10 to start just to make sure we get everyone involved. But in the meantime, I'd love to do some introductions and just get an understanding of why everyone's here. So real quick, my name is Ted Young. I'm one of the founders of the OpenTelemetry project. And I'm really excited that we're in beta and we're coming close to GA and that people are really starting to use it aggressively. So I'm excited to give this series of workshops, and today's workshop, Java, is super interesting to me because Java is one of the core languages in OpenTelemetry and one of the languages that has some of the best kind of dynamic support. So that's me, but I would love to hear from you all. If people wouldn't just mind saying hi in the chat and maybe just giving a one-liner of what brought you to this workshop or what you're interested in. The format's going to be pretty loose, and I really like it to be kind of Q&A focused. So I can customize this to your needs. So yeah, there's a chat if you want to pop that open. Post in there real quick. And in addition to the chat, there's also a Q&A where you can ask questions. So I'll be periodically looking over the chat and the Q&A as I go through the workshop. One thing I'm curious about, if anyone attending this workshop has used OpenTelemetry before or another distributed tracing tool, or if this is your first encounter with one of these, that would actually be super useful. Yes, Mohammed heard about the AWS distro. Yeah, I'm happy to talk about distros. We're actually going to be using the Lightstep distro for this workshop. Distros was a concept that I actually came up with as a way to package up OpenTelemetry and kind of hide a lot of the boilerplate that you would normally have to deal with when connecting OpenTelemetry to a particular backend or service like AWS or Lightstep. Cool. We've got Doug here. Hi, Doug. Doug's been working on cloud computing for the past decade. Awesome. Yeah, you and me both. Looking at service messages, service message and monitoring services and service request performance. Great. Yeah, we don't dive specifically into service messages here, but I do want to point out that Envoy and Nginx have open tracing support, and they'll have OpenTelemetry support soon, if not already. Oh, and we've got Dan from Skyscanner. Hi, Dan. Dan's interested in OpenTelemetry as we're working on a POC for some of our services to migrate tracing from open tracing to OTel. Great. Hopefully migrating to OTel in Q1. Awesome. And metrics in OTel. Yeah, that's coming soon. Yeah, we do have an open tracing shim in Java that works today. So we can go over that maybe in the hands-on workshop portion, just to point out setting that up. But it's pretty straightforward to do. Cool. We got Stephen. Hi, Stephen. Yeah, Stephen's looking forward to getting involved in distributed tracing. Yeah, and hoping that OpenTelemetry takes care of the open tracing, open census split. Yes, yes, that it did. it did that at the cost of maybe a year, but I think it was very, very much worth it. And we've got Chris. Hi, Chris. Chris has been looking at tracing like Jaeger, but haven't implemented anything. Just want to see what OpenTelemetry gives us. Awesome. I'll go over exactly what you get with OpenTelemetry versus what parts of Jaeger you'd still want to keep running if that's the system you want to run. I'm always bummed that these webinars don't let the participants speak, because I think this would be a lot more fun if we could actually have a chat instead of doing it through those little chat window. But I do appreciate y'all taking the time to actually type. Cool. And we're coming up on 9:10. Still feel free to keep posting in the chat even as we get started, and I'll look over there occasionally to answer your questions and also use the Q&A tool. But to get started, first I'm going to start sharing my screen. So you should be able to see the slides. I'm actually going to post a link to the slides in the chat. You're welcome to access these slides and follow along on your own or follow along on my screen. I'm going to leave the slides not in presentation mode so that I can still see your chats and questions. But if you grab the slides, there's actually some helpful links on that first page. These are some things you'll want to do for this workshop. So that the first thing we want to do is account setup. So if people could go ahead and do this part right now, if you just click on this link, that will take you to a free Lightstep account. So if you just sign in like this, made an account with this email. If I use that one. Oh, well, anyways, if you sign in there, I've already made an account, but if you sign in, then you'll get a free account. So we're going to use that to actually look at our traces on the back end during this workshop. So I'm going to sign into my work account here. Great. So that's step one, and we really would appreciate if people go ahead and do that right now so that we can jump right into the walkthrough later. The code for the walkthrough, the code we're going to be looking at, can be found here. So that's a thing you can get started with and maybe go ahead and download. And then these other links are just handy links to the repos. So Lightstep's OpenTelemetry distro is called OpenTelemetry Launchers. There's a link to that code. This is our Bootstrapper code. And after this workshop, if you're interested in learning more, I've got the beginnings of some quick start guides going here. So I'm starting to put together my own sort of set of OpenTelemetry resources to help with getting started. And last but not least, OpenTelemetry Java, the core project. Just so you know where that is. Okie dokie. So that's intros. Those are the links. We'll be getting through to a walkthrough at around 10 a.m. And between now and then, I'm just going to do an overview of OpenTelemetry, discuss kind of the major components. And again, this is very Q&A focused. So as I'm going along, if you have a question, please add it to the Q&A tool here in this Zoom webinar. And I'll be stopping periodically and answering those. And I'd much prefer to do this as a conversation than me just, yapping at the webcam. So hopefully you've got an account, so you'll be able to grab an access token and actually do the workshop. And let's talk about getting started with OpenTelemetry. So first thing people often ask is like, what is OpenTelemetry? Like what is the scope of OpenTelemetry? And we called it telemetry for a reason. This is the Cambridge Dictionary definition of telemetry. I think it's accurate for what we're doing. It's the science or process of collecting information about objects that are far away and sending that information somewhere electronically. And that really covers the part of observability that OpenTelemetry fills, which is the generation and the transmission of the data. So just to get into like the major software components in OpenTelemetry when you're trying to make use of it, the first thing is when you have a service here, so this is green circles, our service, you install the OpenTelemetry SDK. So the SDK is basically the OpenTelemetry client that'll be running in every service in your deployment. So when you're deploying OpenTelemetry, step one is getting the SDK set up and running in every service. So that SDK in turn implements an API. So the OpenTelemetry API is actually a completely separate package from the OpenTelemetry SDK. And the reason for that, there's a couple good reasons for that. One is just clean separation of concerns. The SDK can potentially haul in a number of dependencies. And since it's implementation, there's just a lot more code there. And when you're instrumenting, say, your frameworks and applications, your frameworks, your HTTP clients, all of your libraries, you don't want to necessarily have the fact that you're adding this instrumentation take on a big dependency like all the SDK dependencies. This is especially true if you're, say, like an open source framework that is going to be used in a variety of environments or some shared piece of code. You want to be able to natively instrument that code with OpenTelemetry and not worry about that creating some kind of incompatibility when your library gets installed somewhere else. So the OpenTelemetry API is a completely separate interface-only layer. This also allows, by the way, other SDK implementations to be used. So we have the official OpenTelemetry SDK, but we really see this as a standardization project. And so we want it to be well factored enough that if you didn't like our SDK and wanted to create your own crazy SDK or something experimental, you could swap it out. The SDK itself is actually a framework. So it has various plugins like, exporters and sampling plugins and things of that nature. So you shouldn't have to rebuild the SDK. I'm just pointing out that that's a possibility. For example, wanting to use, say, a C++ implementation through, form function calls, which you probably wouldn't do in Java, but in other languages might be useful. So all of your framework code gets, and your application code gets instrumented through this API. And then once your program is running, all of that instrumentation starts producing data. That data goes into the SDK. It goes into a plugin called an exporter plugin, which then batches that data up and sends it out by default to something called the collector, which is another OpenTelemetry component. So you're not required to run a collector, but we do recommend them. The collectors are the part of OpenTelemetry that allow for data pipelining, data munging, scrubbing, and changing data formats. So OpenTelemetry supports a number of tracing data formats out of the box. OTLP is our own data format. That's what OpenTelemetry uses by default, but you can configure it to use Zipkin, Jaeger, or Prometheus. Those are the protocols that OpenTelemetry ships with. Though, of course, you can always write your own exporters if you want to talk to a different protocol. And these exporters can happen at the language level. So again, you don't need to run a collector. You could just be running configure your SDK to use, say, the Zipkin exporter. But it is nice to do this stuff in a collector rather than in your application, because that takes a lot of this data formatting and data pipelining issue and makes it a purely operational concern. So you're not having to write code and redeploy your application in order to make some kind of change to your data pipeline. Instead, you're reconfiguring the collector and redeploying that component. And I think that's really useful to be able to adjust your telemetry pipeline and make changes to your observability without redeploying your actual applications, especially if you're in some kind of situation that's, actually say you're fighting a fire, or, you're seeing some load issues and you want to change something. It's really a bad idea to be doing a redeploy in that moment. And so the collector kind of takes the weight off of the application as far as a lot of the stuff that you might want to be doing to adjust your telemetry deployment. Now, one thing I'll note is that OpenTelemetry doesn't come with any analysis tools. So the end of the road is the telemetry pipeline, and then that data can be pipelined into a variety of backends. Jaeger, for example, is an open source backend that accepts OpenTelemetry data natively. Lightstep's a commercial one that accepts OpenTelemetry natively. So the reason why we don't ship any analysis tools directly baked into OpenTelemetry is, again, we see this as a standardization process. We want to standardize basically define a standard language for describing distributed systems. So that's OTLP, like an actual structured language for describing distributed systems. And so we think you can standardize how systems are describing what they're doing. But when it comes to actually analyzing that data or doing something useful with it, that's not really something you would standardize. That's actually the area where we want to see a lot of innovation and competition. And OpenTelemetry actually enables that, because if you try to build some kind of cool analysis tool for any of this observability stuff, especially distributed tracing, you're going to discover that a huge amount of the schlep is actually building this ecosystem of plugins and this whole telemetry system. There's a huge amount of code and effort that goes into that part. And if that part's already done for you and all you have to do is build an analysis tool, that really lowers the barrier and makes it a lot easier to build sort of like one-off analysis tools and things of that nature. So I'm really excited to see the world of observability accelerate once we get something like the OpenTelemetry standard adopted everywhere. How OpenTelemetry actually manages its own code ecosystem, since this is, as I just said, a giant pile of code, we do that through a specification process. So the heart of OpenTelemetry is the OpenTelemetry specification. You can find that on GitHub. That's a language neutral document where we define how OpenTelemetry should work, what interfaces it should have, et cetera, et cetera. And then that specification is then implemented in every language. So that's like a super basic overview of OpenTelemetry. Do we have any questions at this time? I'm moving a little fast, so we can definitely do a lot of Q&A here. So Tony asks, does a collector push to Prometheus, or can Prometheus scrape it? That is a good question. I believe it is the poll model that that Prometheus prefers to work with. So I think it may actually work in both modes, but I do know that you can run it in a mode where we will buffer the data and then Prometheus can come and grab it. I'm not a Prometheus expert, but I come from more the tracing side than the metric side, but I do believe that works, yes. Any other questions? Wow, we have a quiet crowd today. Java people are much quieter than Go people, apparently. Cool. Well, if we don't have more questions, I do want to show people around the project. Yeah, about Prometheus, says Andrea. What about Prometheus, though? So let's just look in the specification. I'm going to go into the specification and let's have a look for. So one thing we can do with our time right now is just do a quick tour of OpenTelemetry, the project. So if you go to just GitHub OpenTelemetry, you'll find where everything lives. If you're interested in getting involved in the OpenTelemetry community, like you're wondering how the project works, where to find all of the meetings and things of that nature, the community repo contains a lot of that. This also explains the governance structure of the project. So we have a governance committee, which I'm on, which sort of defines all the rules and kind of bottom lines the project, and then a technical committee, which is bottom lining the specification work. Then every implementation has a set of maintainers, approvers, and triagers that work on it. So it's a pretty large community. We do have some mailing lists that we almost never use. Everyone pretty much hangs out on Gitter. But we do have a calendar because we have lots and lots of meetings. You'll notice there's meetings almost every day of the week. We just got done with the OpenTelemetry specification meeting. The agent and collector meeting is tomorrow. So if you do want to actually get directly involved in the project, or if you have questions, jumping onto Gitter is a great way to get answers really quickly. Posting issues into the GitHub repo will get you a quick response. And if you want to talk to someone live, you can always hop onto one of these calls and ask a question. It's a very friendly community and it's very active. So I would encourage you to get involved since it's still in beta. It's really a great way to get your answers. So cool. So Andreas says, we are encountering some difficulties writing manual code in order to configure Prometheus exporter with OpenTelemetry, because in Java, there isn't much information. Yeah, this is true. It's the biggest problem with the project right now. We don't understand how to export a port on our service, which Prometheus is scraped from. Maybe we could send the information to push gateway. Yeah, that is possibly true. I'm not a Prometheus expert, and I will say the tracing part of the project is farther along than the metrics part. So we're looking at the tracing GAing by the end of the year, but metrics probably won't be done until sometime in Q1, like January or February. So I would say that the metrics side of this is going to be isn't nearly as fully baked as the tracing side. So that's a possibility that you're encountering something like that. But if I go into the OpenTelemetry specification, one thing we can look at is this spec compliance matrix. If you're wondering whether or not something's been implemented, these are all the different features of OpenTelemetry and whether or not they've been implemented on master. So you can see Java here and where Java is at. And you can see for metrics, we're not even tracking this yet because we're really focused on getting tracing complete at this time. But you can come in here and look at the metrics specification. So if you come in here and go to metrics and look at the specification here, you can learn a lot about how this should work. And there may be a Prometheus specification in here somewhere, but it might not be there yet. So yeah, I would recommend popping into either the Java Gitter room or posting an issue saying you're having trouble getting this configured, and they should be able to help you out. We'll also have Carlos Alberto come on at 10 a.m. He's one of the members of the technical committee and one of the Java maintainers, so he can also answer some more Java specific questions. Great. Nothing much else. Well, maybe we can move a little faster. I'm going to see just if I can grab Carlos a little early. See if he'd be interested in popping in a little early. So 1 second. If you do have more questions about how to get this set up, please post them right now. Cool. All right, so I've asked Carlos to pop on. Since it doesn't seem like we have too many questions about the project overview, we can get into something more like, oh, why is this slide here? Never mind. I still have more stuff to talk about. So let's get into some core concepts of OpenTelemetry. So one thing that's core to OpenTelemetry is a concept of a transaction. When we view the OpenTelemetry model of a distributed system as transaction focused, meaning in particular, a transaction that's sort of within the realm of human wait time. So a classic example might be someone trying to upload a photo from an app. So if we look here, like let's say we have a client, and this client's trying to talk to a server and say upload a photo with a caption. But of course, we know it's not just one server. It's going to be talking to a reverse proxy, let's say, that then calls out to an authentication service to check that this is kosher. And then it might download the image to local scratch disk and then call a local application. The application might then take that image off the scratch disk and throw it into cloud storage, and then contact a data service, and that data, and write down where it put the image in SQL and cache it in Redis. So I almost wouldn't even call this a distributed system. I feel like I've been looking at systems that do literally exactly this for 20 years. But you can see even a basic system like this, it's already fairly distributed. You have so many different components here. And as your system grows, it becomes harder and harder to kind of keep track of what logs are associated with what without the right kind of context. You want to be able to find basically all of the logs and events that occur within a single transaction quickly and easily, and do some basic analysis on them. So another view, this is sort of what I would call a service diagram view of a transaction. Another way to look at a transaction is more like a call graph. So in this drawing, we're defining each colored line here represents a service and the amount of time that was spent in that service. So here we have our client. The most time was spent there because the client, was waiting for the transaction to complete. The client then talks to the proxy talks to our auth service, writes down the image, talks to our app, apps talks to a third-party service and our data service, and yada, yada. One of the first things we might want to look at when we're looking at this transaction is, where did the time go? So that's an interesting question to ask, because where the time went is not necessarily where the longest span is. And by the way, we call each one of these transactional hops a span. So for example, the client here is the longest span, the most, from beginning to the end of the transaction, the client took the longest amount of time, but the client was actually waiting for most of that time. So even though that's the longest span, that's not actually where you'd want to look in order to reduce the overall latency. Likewise, you can see here that the amount of time spent in the data service is minimal. So if you went to try to optimize that data service, you wouldn't really be moving the needle very far on decreasing the latency of this transaction. In this particular case, uploading the image to scratch disk and then uploading the image to cloud storage are where the bulk of the time went. So that might convince you, for example, that it wouldn't be worth it to try to optimize this particular transaction because you don't have control over those two aspects of writing the image, or it might encourage you to find a better, faster way to deal with image uploads. So the other thing it shows you, by the way, we call this the critical path, the time spent actively working. And the critical path also shows you implicitly all the time spent waiting. So these are places where you have a program sitting there waiting. If your program's multi-threaded, that's fine. But potentially this waiting might itself be creating some blockage somewhere. So you can learn a lot from just looking at the critical path and looking at where things are waiting. The other thing you want to look at is errors. You want to have an error budget for every service and transaction, and you want to be monitoring errors. And of course, when things do catch on fire, you want to immediately understand where to start hunting. And usually the first place you want to start is where the error actually occurred. So you want to know, was the error originating from the auth server? Was it originating from like cloud storage? Was it originating from your SQL storage? Being able to quickly identify which service to look at is one of the great things you get out of distributed tracing. And last but not least, you want to have contextualized events. So these events are basically logs, right? This is what you'd normally be doing, or at least what I used to traditionally do is just log all over the place. But the problem with those logs is they're not necessarily contextualized, or they're not easily contextualized. I might have a certain amount of local context that I can attach to a log, like a request ID, but there's a lot of context that isn't necessarily available at the call site for that log that would actually be really useful information to index that log with. And so that's correlations. And these correlations are really what makes something like OpenTelemetry and distributed tracing, to my mind, fundamentally more useful than the traditional kinds of logging that you might do. So basically, you kind of have this traditional issue of you have all the logs and you're trying to reconstruct a particular transaction, which essentially means filtering out all of the logs on all of the servers that transaction touched that didn't have anything to do with that transaction. And if you've ever gone through that process, it can be potentially kind of labor intensive, depending on what kind of identifiers you have available. But with something like tracing, it's really, really easy to do. But at the heart of tracing is something called context propagation. So context propagation is what actually makes this easy, but it is the thing that makes setting up something like distributed tracing a little more difficult than setting up something like standalone logging or metrics. So what context propagation actually means is, let's say you have two services and they're in a transaction. So you have some spans, and then you have this network request and some more spans. Within the process, so in process, you need to have a way of propagating all of this context. So we call that a context object. So within your application, as you're going through your control flow, you're trying to follow the control flow and contextualize it. MDC is an example of one of these that exists in Java. There's a variety of them. In fact, there's too many. So we actually had to invent our own context object. We kind of wish this could get standardized, but it's not standardized yet in Java. We do hope it does become standardized at some point. So context gets you context within your program, but for a distributed system, you have to actually propagate that context to the next service. So we call that context propagation. And what that means is at the call site, when you're making, say, an HTTP request, you're taking this context and you're serializing it and injecting it into a set of HTTP headers. So, and then on the other end, you're extracting that context from those HTTP headers, deserializing it into a new context object, and then carrying on. And so this is sort of the core underlying principle that all of OpenTelemetry is built on top of. You have a context object. The context object tends to be kind of hidden in Java, but it is there and you can't access it directly. And then you configure what are called propagators that define when you have something like an HTTP request, what should be injected and what should your system look for on the other end in order to extract. There's a couple of different header types. B3 is the sort of de facto standard that's out there today that comes from Zipkin, but we've also been working on standardizing these tracing headers and actually adding them to the HTTP spec. So a bunch of us have been part of a W3C working group to standardize this stuff, and that header is called trace context. Trace context consists of two header fields. The first one's trace parent. Trace parent contains your trace ID and your span ID. So these are the two core identifiers I was talking about earlier. So if you say, look at this, the trace ID is an ID that's attached to every span and event in the whole transaction. And a span ID is attached to every event in a particular operation within that transaction. So those two identifiers on their own just eliminate a huge amount of work when you're trying to collect all this data together. And that's what enables a lot of these tracing enabled analysis tools to sort of automate a lot of that and do a lot of analysis for you. In addition to the trace context headers, which are sort of tracing specific, there's also a new set of headers we're designing called baggage. Baggage are literally generic key value pairs. So these aren't tracing specific, but this is the idea that once you've got context propagation flowing through your whole system, you're going to discover other uses for this. For example, you may want to propagate something like a project ID. Maybe you have an identifier that's available in one service early on, but it would be expensive to go try to grab that identifier from every service down the line. And so rather than doing that, you could simply add that project ID as baggage, and then it would propagate to all of your downstream services, and you could have access to it as an index. You could also potentially use baggage for non-observability things, such as say feature flagging or A/B testing in a distributed system, being able to know whether you're on the A side or the B side, some information that you could flow through with baggage. You could potentially use it for authentication. I would hold off on anything that's system critical and dependent on baggage at this point, just because it's all new. And while observability is important, it doesn't break your system if observability has some kind of hiccup. But in the long run, I expect to see a lot of interesting sort of cross-cutting concerns get handled, find baggage to be like a really useful tool for implementing them. And then last but not least, we're going to get into SDK setup. So if you're going to like actually sit down and start attaching OpenTelemetry to your services, before you actually do that, there's some things that you want to check. You want to verify first and foremost that the frameworks and libraries you're using actually have instrumentation plugins. So, you know, getting back to this diagram, if the HTTP client and the HTTP server aren't instrumented with OpenTelemetry, then inject and extract won't work. So most of the heavy lifting is done through instrumentation plugins for open source or shared code that you're using in your application. Ideally, you don't actually have to add any application level tracing or logging in order to get a complete trace, in order to get really enough information and visibility into your system. Should be available just through installing these different plugins. But you do want to make sure that OpenTelemetry actually supports the frameworks and libraries you're using. In particular, your application framework and your HTTP and database clients are the ones that are most important. You want to make sure that context propagation is working once you get this set up. That's one of the areas where things can break most easily. And it can be a little mysterious because it's potentially normal to say get a request that doesn't have some context in it. So this can be a silent error. And the way you ensure that you don't encounter that is to ensure that you're using the same context propagation header everywhere you go. And that's why we really want to standardize these headers, because if they're not standardized, then you run the risk of service A not being able to talk to service B because one's expecting trace context and the other one's sending B3. Okay, now we're going to get to the code walkthrough. But before we do that, are there any other questions that people have on what we've just been talking about? I see Steven's got a question. We have a lot of investment in homegrown metrics pipelines. We 100% want tracing, but do we have to be concerned about the performance impact of OTel also gathering metrics, or is there a way to just disable that? Yes, OpenTelemetry is totally a la carte. So you can just use the tracing portion and disable the metrics portion. It's also very light on the metrics front. I actually believe a lot of the metrics that you want, you can actually get from aggregating your tracing data. And you don't necessarily, and if you have an analysis tool that will let you do that, let you actually make aggregates and histograms and various like metrics dashboards from counting trace data rather than going into your code and putting a bunch of instrumentation points in there. I think that's a really useful way to move the burden of a lot of your metrics works from actually typing code to just setup that you're doing on your backend. But there's of course also a metrics API that does a lot of useful things. It's also very efficient for calculating a lot of like pre-calculating things you might need to do some of this aggregate work. So you can turn it off. You don't need to use it. And you could also potentially write a metrics plugin that simply piped those calls into your custom metrics pipeline. Okay, and Daniel's got a couple of questions Q&A. Oh, sorry, Daniel. Wow, scroll button. Okay, let's get through these. So Daniel asks, what is the recommended migration path from OpenTracing to OpenTelemetry? We're thinking of starting with the shims, but can we expect the shims to be compatible long-term? Yes, so that is the correct migration path. So if you already are instrumented with OpenTracing, then you've got the API layer done. So if we go back up here to this diagram, you're saying OpenTracing is just an API layer, and OpenTracing was designed to talk to a variety of implementations. So you would take the OpenTracing API, and then you would build a client implementation of that. And so there are lots of implementations of OpenTracing, and OpenTelemetry is just one more implementation of OpenTracing. So this is actually precisely how OpenTracing was designed to work. And so when you install the shim, all that does is it allows all of your OpenTracing API calls to be collected by the OpenTelemetry SDK. So I would say step one is, if you're looking to migrate, is to first migrate your client from whatever client you're currently using to the OpenTelemetry SDK. You shouldn't have to change anything else. You will potentially want to disable any auto instrumentation that the SDK is doing, though. I would say that's the one thing, maybe the one gotcha. You don't want to double install instrumentation because that might lead to a lot of weirdness. Open tracing and OpenTelemetry API calls can be mixed, though. So they, if you're creating spans in open tracing, they'll be available through the OpenTelemetry API. So you will be able to progressively migrate your system over if you want to eventually get rid of those open tracing API calls. But there's no need to do that. We're looking for a very long-term backwards compatibility there. They're minimum of 2 years. And in general, the project is very, very, very backwards compatibility focused. So it's in beta right now, but once we've 1.0'd these APIs, we are going to adhere to a strict backwards compatibility guarantee. So there might be some breaking changes to, say, some of the internal APIs within the SDK, but this separate API package, the plan there is to make it never break. So we might add things to it, but we never want to break everyone's instrumentation, because this is the stuff that gets out into the wild and there's millions of lines of it written. So that's the other reason why the API is separate from the SDK. Okay, so thanks for your questions. Let's move through some of these. So hopefully that answered your migration question, Daniel. Please follow up if it didn't. Chris Vogel asks, did you see any interaction between OpenTelemetry metrics and the micrometer Java library? We communicate with Micrometer crew regularly, and again, that's a very similar project to open tracing in a lot of ways, where it's mostly just an API and a layer that lets you kind of mix and match things. So that's that should be compatible with OpenTelemetry as well. I think we did look at potentially using the Micrometer API, but because OpenTelemetry is kind of a cross-language project and Micrometer is Java specific, we didn't end up doing that. But they should be compatible. And again, if you're happy with Micrometer and you just want to add tracing, that's totally fine. There's no need to use OpenTelemetry metrics if you want to use another metric system. Likewise, if you wanted to use OpenTelemetry metrics but another tracing system, that might potentially be feasible, but I think that'd be a bit trickier. Great. Cool. And we've got Carlos on the call as well. So hi, Carlos. Carlos is one of the members of the technical committee and one of the Java maintainers. So he could answer some of your questions. Actually, we've been getting some Prometheus questions, Carlos, and I was curious, do you happen to know the state of the Prometheus exporter in Java? Is that stuff working right now?
It's working. I'm not very familiar with Prometheus, but we have had the exporter for a few months now, so it should work overall.
Yeah. Do you happen to know if it's a push or pull model?
I'm not aware of that.
Yeah. You have people from the tracing side on this call. Apologies. There's also a strong metrics community, and if you're interested in metrics, there's a metrics specification call that happens once a week, and if so, that's a place you can hop on to get access to all the metrics experts. Okay, so Carlos, we're just going through some Q&A now, and then we'll be moving on to the code walkthrough.
Sweet.
So Tony asks, how do you differentiate between network latency and service latency? You can notice the difference between network latency and service latency by basically the gap in time between the client span and the service span. That's a rough way of getting network latency out of the system right now. We don't have currently don't have anything that specifically hooks in and just measures the network portion of that, but you can deduce it by looking at the difference in time spent on the client versus the server. The difference in time represents the network latency. Daniel asks, can OpenTelemetry Tracer propagate context with multiple propagators while injecting and extracting? Yes, we can. So OpenTelemetry comes with what's called, I think, a compound. We used to call it a stack propagator, but I think it's called a compound propagator. And you can set that up to look for multiple types of context coming in, so it can scan in order when you configure it to say first look to see if there are trace context headers, and if it doesn't find trace context, it looks for B3 headers. And then you can also configure it when you're injecting to inject all the header types. So rather than just inject one type, you can inject both trace context and B3. And that can be a useful way to transition your system. So if your system, say, currently running B3 and you want to have a zero downtime transition over to trace context, then you can configure your compound propagator to propagate both, get that deployed into all of your services so that both are getting propagated, and then remove the B3 from that list. So obviously there's extra overhead when you're propagating both kinds of headers, but it's fairly negligible, and that's a great way to do a sort of rolling transition from one header type to another. Tony asks, what would a trace look like where an async call to some service didn't complete? The service which was called died before writing to the collector. So if the service dies before a span completes or exports, then you'll lose that data. So the way OpenTelemetry exporters currently work is they're a sort of buffer-based model. So they buffer spans locally, and then once you've hit your max buffer size or your timeout, those spans are then flushed. So that one gotcha you will have is if your service suddenly gets killed before those spans get exported, you won't be able to get that data. Unfortunately, that is a limitation right now. We're looking at adding some shutdown hooks and things to Java in particular. Some other languages have this already to help ensure when your system's shutting down cleanly that all of that information gets flushed. But that is a gotcha. It's a particular gotcha in a serverless environment where you may have systems spinning up and down really quickly. If you do encounter something like that and the volume is low enough, you could switch from the batch exporter to the single span exporter, which will flush a span every single time it gets one. And I would be interested in potentially looking at a more event-based model in the future so that it might be possible to collect partial spans. So there is a protocol we've experimented with, but probably won't implement, till we're well on the other side of GA, that involves basically sending out individual span events, start span, event, add attribute, end span, and just spewing that all out over UDP to a sidecar. We've tested out some of these other streaming protocols, and we think they work really well. But one thing that doesn't play well with streaming is wanting to have some kind of something in your process that actually wants to collect the whole span and then look at all of that data and then say manipulate it before it goes out the door. So that's part of the issue. You can't really have both. But if you move a lot of that processing out to the collector and make the SDK leaner and just something that's streaming out data, then you could potentially have something like that. So I would say that kind of stuff is what we want to look into after we GA. Right now, we're just trying to move the core model that Open Tracing and Open Census used, and the kind of the buffering model that was used at Google. We're kind of sticking to that for the first version. Cool. Okay. I think we've gotten through the Q&A for now. So let's see if we can hop in to an actual walkthrough here. So I'm going to do the walkthrough, but it's great to have Carlos on the call just in case I'm doing something silly in Java. But what you can do is you can follow along yourself. So if you go to the links that I sent out earlier and go to our Java launcher, or sorry, not the Java launcher, you do want that, but going to Hotel Java Basics, this is the walkthrough code that we're going to be using. So if you haven't created an account, please do that now, and go ahead and download this repo if you want to follow along. Otherwise, you can just watch me do it. But I find it's more fun to play with it yourself. So what you need to do is download that repo. I'm going to stop sharing this. I'm going to start sharing my code. So the first thing you want to do is grab this and just run make. And that will download all of the components you need. And if you're wondering what this is doing, please just check out the make file. It's pretty simple. But basically, you're going to need to download the Lightstep Java agent jar. So this is the Lightstep's wrapper around the core OpenTelemetry agent. I should mention that the primary way and recommended way to work with OpenTelemetry right now is using a Java agent. It is possible to do it all manually if you like, but we really strongly recommend the agent approach. So if you download that and then want to actually connect to Lightstep, you need to have an access token, which you can set as an environment variable. So the way to get that access token, here I'm just going to share my whole screen so I don't have to keep hopping back and forth. So if you go here to your Lightstep account, you'll see there's this little settings wheel over here in the corner. And if you hop down to that, you'll see there's an access token, and you just want to grab that. And then you want to just add that to your environment variable. You can also set this as a system property, but just doing environment variables for now. And I'm going to add it to this other window because I want to run both a server and a client. So. Cool. So once you've added your access token, you should be able to run this and just see a bunch of spans. So we're just going to do that. You can run it by first running the server. So make run server. You're going to see a lot of building going on. You'll see the command lines added the agent. We've set a couple of different configurations. So one thing we've done is we've named this service Hello Server. That's important to always add a service name so that you can identify the service that's issuing the spans. Propagators, we've configured this to propagate both trace context and B3 as per that discussion before. And then we're also adding resource attributes. So resource attributes are a way to actually index your services. So it's not just adding indices onto your traces. You also want to add indices onto your services that these traces are flowing through, because that's another way to correlate data. And OpenTelemetry auto detects a number of useful indices, or sorry, number of useful resources such as host name and things of that nature. But you can also add your own attributes. Currently in Java, this is supported through a system property, so you can pass them in as a key value pair. So I would say that's useful approach. And then here we've just reduced the delay on flushing the data so that we're not waiting a long time for the data to show up in our backend. But normally you'd want this in production to be a much higher number. Cool. And so that's it. And that gets our service started. And then on our client, we're going to say make. Actually, I need to shrink this a little bit, or I can't see your questions. So make run client. And what the client does in this walkthrough is it makes 5 requests to this service. The service just prints out hello world. But all 5 of those requests are themselves connected into a single transaction by a parent span. So what we'll see on our backend is a trace containing 5 requests to this server. Oh, we're getting a timeout here. Possibly just because I'm running it in these terminals here. So if I run it out here, you just say make run the server. Get the server going. And up here, say make run client. Okay, and that exited cleanly. So we successfully connected to our server from our client. And so if I just go into Lightstep and look at our Explorer here, I'll see these spans coming in. So here we can see a bunch of data coming in. And if I click on any of these, we'll see the overall trace. So here's an example of a trace view. And you can see this black line here represents the critical path. You'll also notice that there are errors going on. We added an exception to one of these, and I'll show how that works. But if you do capture an exception and count it as an error, then it'll mark the entire span as an error. And you can use this for error budgeting and calculating error rates and things of that nature. Looking at the actual data that comes in, we can see a bunch of interesting information. Instrumentation name tells where this data actually came from. So you can see which package actually created the data or created this particular span. You can see, some additional pieces of interesting information. And if you look here under details, you can see a lot of information about the service that this came from, the platform, client library version, the host name, etc. And if you look at a span that represents an HTTP client, you'll notice that it has a bunch of HTTP and networking information added to it. So all of these attributes are standardized in OpenTelemetry. One of the things we want to do is make sure that an HTTP request looks like an HTTP request, regardless of where it came from. And so if you go look at the specification, you'll see that we have what we call semantic conventions. And these semantic conventions basically describe how you should observe these common operations. So if you're writing your own instrumentation, I strongly recommend giving these conventions a once over and using them when you're describing something common, like an HTTP request or a database request, or anything of that nature. Cool. So let's pop in and look at some of this code that's actually generating this data. Oh, and we've got a question from Daniel. Daniel asks, last year, the microprofile spec specified that operation names and service spans should be of the form get path to span. As far as I can tell, OpenTelemetry spec does not mention a convention on names for service spans. Do we want to formalize this? Yes, we do have conventions. So you will notice that these spans get named something specific. So for HTTP spans in general, we have some specific recommendations about what it should be. The ideal span name is a route. One issue with naming spans is you don't want something that's too high cardinality. So something like API users 123, like a path such as that the cardinality of that is too high, because you don't want to be looking at, you want to be bundling up all requests to this particular endpoint, not splitting it out by individual variables. On the flip side, if you don't have routes, you need to go with something a little bit simpler, which is just HTTP method name. And so this is a little too low cardinality because you don't necessarily want to look at all just the HTTP gets across your system, but you can scope this down a bit by looking for, say, gets coming from a particular client. But ideally, you're getting this routing information in there if you're using a service that, if you're using some kind of web framework that has a concept of templated paths or routes. That's the ideal name for an HTTP span. And we do have general guidelines for span names that get into a lot of these details. So you post that into the chat. So yeah, this is a useful read through if you're thinking about making your own spans and your own operations. Daniel then asks, I understand you're supposed to be using operation names for statistically significant groups of spans. That's perhaps why the method is useful in the service span. Yeah, post is very different from get. Yeah, this is true. Post is different from get, but it's a little too generic. Get account is with 42 is too specific. Something just like get account, like a handler name, is good, or a templated path is also good. So either of these are kind of the level of granularity you want with your span name. Okay, so popping in to some actual code, let's have a look. So if you look at this this walkthrough code, it's a very simple client server example. So here we're just setting up a little Jetty server. And since OpenTelemetry comes with a servlet instrumentation out of the box, it's automatically instrumented. So we've added some additional instrumentation in here just to kind of explain it and show it off. But I do want to stress that you don't actually have to write any code. You'll get most of the information you want directly from the instrumentation that's automatically installed by the agent. But if you do want to add additional data to your application, here's how you do it. So the first thing that you want to do is get a handle to your tracer. So if you're going to be doing tracing related operations in your class, you just want to get a tracer and you want to name it the fully qualified name for your class. This is what's going to let your backend know that, where are we looking here? Where that instrumentation came from. So here we can see that this particular client span, the instrumentation was in auto-installed instrumentation from OpenTelemetry for OK HTTP. And so if you're going to add your own, you want to qualify it in a similar manner. So that'll give you a handle on a tracer. And you can use that tracer to build your own spans. So just to give an example of what that looks like, let's say you have a sub operation that you want to measure the latency of. To do that, you grab your tracer and you create a span with a span name that you've thought about, hopefully according to those guidelines. And then you start that span. If there's already a span running in this current context, which in this case there is because we are in a handler for an instrumented service, there's already a span running. You can access that span that's currently running by calling, we have a utility class that makes this real easy. So if you want to pull that out of the context, you just call get current span, and that'll give you the currently running span. So for example, in this case, since Jetty doesn't add a route name automatically, I'm manually setting the route here. So I'm not changing the span name, but I am adding a route semantic convention as an attribute. So you could index on that. But that's how you access the current span. If you want to create a child span, you grab your tracer, build the span, and then start it. And so that'll give you a running child span. If you want to then measure something with that, you can just kind of grab this span, do stuff, and then be like, end the span like that. So that's start and end. But this doesn't actually change which span is active. You've just made a span locally. So generally speaking, when you create a span, you now want to make that span the span that's active in your current context so that it'll follow the flow of your application. And to do that, you create a closure. So by calling with span with that child span, inside of this try block, get current span will now return this new child span. So just to be clear, out here, get current span is the span that was created by our Jetty instrumentation. And inside of this try block, get current span returns this new child span. And so this is how you set up the context aspect of context propagation. Oh, and just by the way, spans have a kind of chaining API. So it's easy enough to just get the current span, perform a set of operations on it. So let's say we want to we added an event to a child span here, but we could also add an event here. Just like this. So that's like a pretty kind of concise and convenient way to just do kind of quick logging, quick attribute setting, things like that. It's also easy enough to wrap this stuff up in your own shortcuts, which is a thing I recommend. The OpenTelemetry API is a little low level, and usually you'll end up with like patterns of things you're doing in your code, and it's easy enough just to create a little wrapper like this to make that easy to do, or at least take up less space on your screen. So there's some other special things that you can do. One special thing is recording exceptions. This is a special kind of event. If you're just doing regular structured logging, you use add event. But if you have an exception you want to record, a record exception will create the right semantic conventions and make sure it looks uniform on your backend. But notably, if you record exception, this won't automatically count this span as an error, because not every exception is an error. In order for a span to count as an error, you need to set this status to error. And so these are two separate things. So, it's possible to have errors where there wasn't an exception present or access to exception. It's possible to have an exception that doesn't count as an error. So you do need to do both. Another thing you can do is just grabbing a current span and setting it to error. This is a pretty common approach if rather than creating child spans, if you're in your HTTP handler and you're like, this handler, you hit an error path, you can just set the status code to error, and that is what will cause it to look like an error in most backends, like here, for example. So going over to some questions now. Daniel asks, I understand you're supposed to be using operation names for statistically, oh, we already answered that one. Tony asks, how does Tracer span builder work with async code? How will it determine what the correct span to use is? Carlos, you might be able to answer this one better than I can.
Yeah, sorry, what was the question? I was reviewing.
Yeah, so the question is, if we're looking at span builder here, the question is, how does this work with async code? So if you're doing asynchronous coding, how would you track the current context?
Usually in that case, you could use instrumentation that automatically activates and deactivates a span. So behind the scenes, for example, if you have something like a thread scheduler, or a thread pool, every time a task is sent to a thread, the span will be activated or set as current. And then before it goes to the next thread, it will be deactivated. Yeah, this can be manually, but it's a lot of work usually. But hopefully auto instrumentation or instrumentation in general should help that. But yeah, that's the thing, because essentially every time you change a thread, you need to do this activation and then of course deactivate the span.
Yeah, and there's, I think, a general point there, which is ideally you kind of want to centralize a lot of this work. You don't necessarily want to be, every time you're making an async call, or in every handler setting up and manually doing a lot of this. If it's remotely repetitive, you ideally want to pull this out of your application code and centralize it somewhere, or turn it into a wrapper or something of that nature, just to keep your code clean and to keep things regular, especially given that this has to get deployed across all the different services and service teams in your system. The less you have to do by repetitively writing application code, the better it is. And honestly, this goes for logging and everything else too, but I won't get into that.
And to be clear, I think that a lot of users are afraid of how this will work with asynchronous frameworks. So this is actually very simple, but it's very repetitive. So yeah, just go use instrumentation if possible. If we don't have instrumentation for that, you can always ask us to write one for you. Like just tell us what framework you are using, like Scala, Akka, and then we will try to get some instrumentation done.
Yeah. We also do have some convenience. So you'll notice that, creating a scope in a try block in a span is a little bit of boilerplate. And if you've already wrapped this up inside of a method, you can use the with span annotation. So with span will automatically wrap this method in essentially, this kind of a try block with the child span. So this is maybe, again, like a cleaner way to be adding more spans to your system. Though I do want to recommend you don't necessarily want to be making lots and lots of child spans. We can go into some of those details later, but ideally you want to have fewer spans that have more correlations and more attributes on it, rather than lots and lots of small spans. You should only be creating child spans if you're specifically trying to measure the latency of a particular operation. So sometimes people think like span equals function, like every function should be wrapped in a span, but that's actually overkill, serious overkill. Okay, so that's the basics of span creation right there. So you'll see this pattern a lot. But most of the time, as I said, you won't need to actually create your own spans. You can just access the current span. And if you want to be able to correlate the span, you can add attributes to it. So here we're adding project ID 456. This will allow you to find all of the spans in your backend. So just for example, here, if I go project ID 456 and just do a query like that, now I can see all the spans in my system that had 456 on it. This stuff might have gotten flushed out of here already. But here, let me create some more data. Oh, I broke something. That was probably it. Nope. Probably did something dumb over here. There's always one thing, which is creating some more data. That guy running is, and then running the client. And then we need to just wait for it to flush the data. There it goes. So now I can pop in here and I'm looking for anything that has project ID 456. We should be seeing some of those show up. If I just do a clean query. Yeah. Like that. So, okay, so here's all the spans that are associated with project ID 456. And then I can look at that span and see the whole trace, and then look over here and be like, well, what about everything that was associated with this hello route? That's kind of interesting to me. And then come back here and see everything associated with hello. And then you can pop back into that span. And so kind of going back and forth, looking at a trace, trying to get to the bottom of it, noticing that there's some correlation you might want to look across, checking out that correlation in aggregate, then seeing something interesting pop up here and diving back into the span. That's a common, super basic common workflow for investigating your data. Obviously, you can do things that are a lot more complicated than that. But for me, I find when I'm trying to kind of diagnose a system, this is sort of how I start looking around. There's, of course, a lot of tools that different systems are going to build that allow you to sort of automatically show correlations and things of that nature. So hopefully there'll be more and more fancy things. But this basic pattern of looking at your correlations to sort of move around through your data is super great. And I don't know, I find this impressive because having in the past, having to do just lots of querying and filtering to move around like that, I've used to find this kind of stuff to be somewhat laborious. And with something like distributed tracing and OpenTelemetry, it's a lot more straightforward to do. And that's basically it. So really all you need to know to actually use OpenTelemetry is to the instructions for installing the agent, and then this super basic set of operations, just grabbing the current span whenever you want to add more of these correlations so you can do the workflow that I just showed you. creating child spans and setting them as active, recording exceptions, setting your status to error, and then of course adding events, aka logging. And there's lots and lots more to OpenTelemetry, but really like as an application developer, that's your bread and butter. That's all you should really be interacting with on a day-to-day basis when you're dealing with tracing. And of course, there's also metrics, but we're not going into that today because it's not fully baked yet. So that's a basic walkthrough here. Do we have any questions about the walkthrough at this time? After that, we're going to go on break for a bit. And then when we come back, we're going to talk about advice, best practices, how to roll this stuff out in your organization, things of that nature. Cool. Well, we're going to go on break. So it's 10:30 now. We're going to go on break for 30 minutes and come back at 11. And we'll be diving into more of these details at that point around best practices. But if you're around on the break, I really encourage you to play around with this walkthrough code. See about modifying the API calls in there and seeing how that changes your data. Try adding a new semantic convention, things of that nature. If you do run into some hiccup, if for some reason you're not being able to get this connected, just post a note in the chat and we'll see if we can sort you out. And otherwise, we'll see you at 11. Thank you. Hello, everyone. Coming back from break. If anyone had any questions over break, hopefully people got a chance to play around with some of that code. If you do have any questions or comments, please post them in the Q&A or the chat. Okay. So we're coming into the last part of the workshop here. So we're going to move back out to kind of talk about some of the more soft issues around best practices, rolling out OpenTelemetry, things of that nature. So we've already talked about this a bit, but one best practice is around naming of spans and how many spans you should need in your system. Does a span a function? Is a span a library? Where does it live? There's a couple of scopes you can see when you're looking at a trace. Transactions, like the largest scope, then your process, then transition between code bases, so like every library that your code winds through, and then of course functions down at the bottom. And spans represent operations, which is usually a granularity somewhere larger than a function, but maybe smaller than a library. maybe it's a single span representing all the work that that library did in a trace, like all of the work that a database client might be able to be encapsulated into a single span. But there may be some sub operations within that database client that you'd want to measure. So it's usually, I would say, maybe 1 to 3 spans per library if you want to use a rule of thumb. But I would strongly recommend aiming towards fewer rather than more. And part of the reason is, one, spans are a little more expensive. So the overhead of doing the measurement of the timing is small, but it's still overhead. So measuring things that you're not necessarily going to look at isn't necessarily the greatest idea. You can use events to measure things. You can obviously look at the time between events. When you're trying to create spans and operations, you're really thinking about operations that you'd want to be setting up, say, some monitoring for, not proactively wrapping every function in a span. It's also, as we saw, before, starting and finishing spans means you have to, create a try block and a scope. So that can be a little bit bulky. Ideally, you don't have too much of that going on in your application code. And there's also some practical aspects around being able to actually index and look up these spans in your tracing backend. So, Lightstep, like a lot of systems, you can look for spans. You can do queries based on attributes that are on a particular span, but it's harder to do queries where you're looking for, I want to find traces where span A has the route hello and span B has a project ID 456. It's usually easier for these systems to have a single span that has both, project ID on it and HTTP route on it. So for that reason, you want coarser grained spans. You want to have as much of the indexing on a single span as you can get. That will give you the best experience on the back end. Though obviously you still want to sometimes create child spans if you're trying to measure, specifically measure the latency of a particular operation. So yeah, that's my main advice. And then also, as much as possible, try to keep a lot of this observability stuff, inside of your framework code and not dirtying up your application code. I know we have a tendency to pepper application codes with logs. You can still do that with span events, but in general, you should try to think of a way to get this out of your hair so you're not copying, pasting a lot of observability code all over the place as you're trying to write application code. Does that make sense to everyone? I think that's pretty straightforward, but if people have questions around, span size and operation stuff, we could go into that now. So otherwise, we can move on, and please continue to post questions even after we move on. But let's move on to getting started. So the thing about distributed tracing is you have to install it in every service in the trace. So unless your organization is very small or very centralized, you may need to have a rollout plan to get started here, especially if you have a lot of service teams and a very large system. So one thing that's important when you go to roll out something like OpenTelemetry is to have a goal. If you look at the amount of code involved, the vast bulk of the code is going to be in instrumentation. Hopefully most of that instrumentation is already written for you, as I said, but installing and writing instrumentation is where potentially a lot of the work is going to be. And so you want to avoid sort of boiling the ocean when you get started. What I kind of recommend, if you're gonna, if it's not a kind of situation where you have a sort of centralized infrastructure team or a centralized code base where you can set it up and deploy OpenTelemetry to all of your services all in one go. If you can't do that and you have to go from service team to service team and install it service by service, try to find some kind of high value transaction. It might be something where you're already having issues or you're already concerned about the latency and you'd like to reduce it, or it could just be a really important transaction in your system like checkout or something like that. But have some kind of goal that's high value and important, and try to do the work of instrumenting that transaction first. So finding all of the services that are part of that transaction, getting OpenTelemetry installed, making sure context propagation is flowing and that you can get a proper end-to-end trace for at least one transaction that people in your organization understand and care about. If you do that, then it becomes a lot easier to explain the value of distributed tracing, and you can potentially get there faster than trying to add OpenTelemetry everywhere. Once you get that one trace going, hopefully, that alone should give you some insights, especially if you've never added a latency monitoring tool like distributed tracing. If this is your first time adding something like that to your system, I find things will often just pop out. There's often some low-hanging fruit hanging around, places where, say, operations were serialized, where they could have been easily parallelized, things of that nature. So you want to start hunting around for those sort of low-hanging fruit, just looking for latency outliers or average latencies that seem strangely long. And then going back and adding details to your trace as you go. So I kind of recommend, rather than trying to deeply instrument every service, just trying to get that framework and library instrumentation installed and getting that high level trace going. It's more fruitful to have a complete high level trace than a lot of detail in a potentially unconnected trace. Which is honestly how I do see these things go wrong sometimes. Like when I've seen it become difficult to actually roll out tracing within an organization, it usually follows a pretty common pattern. Someone gets really excited about tracing. Maybe it's one of you all on the call today, and you decide you want to roll this out. So you go back to your company and then kind of go around to each service team, trying to encourage them to add this. Maybe some teams add it, maybe they don't. Maybe some other teams are more interested in observability than others. And you end up with this sort of scattershot approach where you don't really have complete traces, and it's a little bit hard to show the value of distributed tracing. So that kind of approach can often lead towards the effort petering out before any kind of like success is reached. So that's the number one thing you want to avoid, is some kind of inconsistent rollout where you're not getting complete traces. And Tony asks, do you know if there's any scope use a service mesh, for example, Istio, to avoid having update all services? I see. I believe you're asking, is it possible to say roll out distributed tracing through your service mesh? I think this is what you're asking, Tony. Like, can you just, if you have a service mesh running, can you just enable distributed tracing in that service mesh and not have to go into your application server and add it there? And that would be awesome, but unfortunately the answer is no. And the reason the answer is no is your service mesh can see ingress and egress from your application, but it can't flow the context through the application, meaning you can't, there's no way to determine what ingress matched what egress, if that makes sense, because within your application, you're not going to be flowing those trace IDs. So the service mesh would have to be holding on to the trace IDs during ingress and then looking for the egress and reattaching them there. And there's just no realistic way to do that. So instrumenting service mesh is a useful way to get a lot of data out of your system, but it's not a replacement for at least enabling the basic context propagation of OpenTelemetry within your application. So hopefully that explanation makes sense. If it doesn't, let me know. I'm happy to go into details there because it's a pretty common question. So yeah, again, like the pitfalls that I encounter when people, try to kick off an observability effort within their organization is, again, if this involves like multiple teams, a lot of engineers, you do want to have a certain amount of project management. I know as engineers, we have a tendency to maybe eschew that, but getting those team organized and having an organized effort really does make a difference. So if you feel like maybe you're not positioned to do that, maybe the first step is to go find an engineering or project manager you can pitch to help you with the project management aspect of connecting to the different teams and having a planned rollout. And then it's also helpful, as you may have noticed, there's always going to be tons of questions about distributed tracing. It is kind of a new thing, and so when people get started with it, it can be a little confusing, especially the context propagation part. So I really recommend centralizing all of those resources, maintaining some internal documentation that's specific to your organization as much as possible, making the instrumentation a thing that lives in shared libraries, so people are not having to manually instrument every handler or route or something like that. And then coming up with your own semantic conventions that are specific to your organization. So there's all the standardized conventions around things like HTTP and SQL calls, but surely your organization has its own concepts that you'll want potentially standardized. So, you want it to be project.id everywhere, not project.id here and project-id there and project camel case ID somewhere else. So standardizing and sanitizing the data that comes out of your system is another thing that can be really helpful. And again, if you can add all of that in some centralized place, so individual application developers are not having to remember to add it themselves, that makes the whole thing smoother. And so those are like the basic pitfalls. I do have a short pitch here that they asked me to do. If you're looking at rolling this out in your organization and you would like help, we're looking at offering like an OpenTelemetry quick start. So this would basically be a consultation with Lightstep. You don't have to be a Lightstep customer. You don't even have to use Lightstep. This is purely an OpenTelemetry support offering. We're checking out whether or not this is something people would actually want. So this would basically be an engagement with us to come into your organization and just hands-on keyboard help you actually set up OpenTelemetry. So if something like that's actually interesting, you can contact us at support@lightstep.com, and we'd be happy to help you set this up. So hopefully you can get it set up yourself, but if something like this looks like it would really facilitate the effort, this is a thing we're happy to do. I don't think it's that expensive relative to what you'd get out of it. So if that's interesting to you, support@lightstep.com. And that's basically what we have for this workshop. I want to just sort of do a brief overview of where everything is at, just so it's clear before we go. At this time, the betas that I consider to be production ready are Go, Python, Java, and JavaScript. Other languages are coming along. I do want to stress that while we're close to GA, these languages are still in beta. So you are going to see potential breaking changes to the API. Again, if you stick to the automatic instrumentation, that'll really reduce any potential pain there if we break an API. Once we hit 1.0, we're going to lock those APIs down hard, and it won't be a problem after that. If you're looking for just the basics of the project, of course, OpenTelemetry IO, that will give you access to all the different repos. We're adding official documentation there soon, so you'll see more and more resources showing up on that website. I also am starting to put together and maintain my own set of resources, and that you can find at otel.lightstep.com. We have getting started guides going for these languages right now, but I really want to add a lot more detail, things like cookbooks, deep dives, software framework or database specific thoughts, message queues. There's really a lot of different areas that I think would be helpful. If there's anything in particular you'd like to see, please let me know. You can DM me at Twitter. I'm Tetsuo on Twitter. I'll be posting regular updates there about OpenTelemetry project, plus any additional resources I'm creating. So you could follow me on Twitter if you want updates about all of that stuff. And last but certainly not least, if you want org buy-in, basic strategy is pick a known pain point, instrument only what you need to get that single transaction completely instrumented by installing automated instrumentation via the Java agent. And then from that point, start looking for other outliers and low-hanging fruit, and then expanding the effort from there. And if you are looking for more help and you'd like to chat, there's, of course, Gitter, where you can find the OpenTelemetry community, but you can also check out our own Discord. So if you're looking for a place where Lightsteppers hang out who work on a lot of this stuff, we're starting to run a Discord now. So you can pop into there, and that's a great place to just pop in and ask quick questions while you're trying to set this all up. And that's the workshop. Thank you so much, everyone, for coming. We've got about 10 minutes left. Oh, thanks, Tony. Yeah, I appreciate you as well. If people have any final questions, I'm happy to hang out for the next 10 minutes and answer them. So Daniel, drama, contentious question. OpenTelemetry distros are great, but doesn't it go against the openness of OpenTelemetry when some distros contain proprietary receivers exporters that are not the core OpenTelemetry or OpenTelemetry contrib repos? What is my take on that? I don't think it does. The core, so I will say first and foremost, if it's only an OpenTelemetry distro, in my book, if you can continue to configure OpenTelemetry beyond what that distro does for you, and that it interoperates with any other plugin, basically it can't be a fork. If someone actually changes up their distro to the point that it's incompatible with other things you might want to install or use with OpenTelemetry on the same service, that's not a distro, that's a fork. And it's open source, so people are, of course, welcome to fork it if they want, but distros are really just a prepackaged version of OpenTelemetry. And they may contain, I've yet to see a proprietary exporter, but they most certainly contain exporters and other code that's specific to a backend. So AWS is an example. They released their own distro recently, and part of why they needed to do that is when you connect to X-Ray, they have their own data format that nobody else cares about, and they have their own sampling algorithm. And so if you want to connect to X-Ray, you have to install that exporter and that sampling algorithm, sampling plugin, and configure them correctly. And if you forgot to do one of those things, you would have some funky sort of half set up system. And so that's sort of the concern, is rather than telling end users, here's a bunch of boilerplate, go do it yourself, and then potentially get something wrong, why don't we just package up all of that boilerplate, since most of it's sort of specific to an individual. Another way of putting it is a lot of the flexibility in OpenTelemetry is about connecting to different systems. But once you pick the system that you're going to connect to, most of that configuration becomes boilerplate. And especially forgetting to install a sampling plugin, that's sort of like a foot gun waiting to happen. So I wrote about this in more detail here. Let me just paste this in. So this is the blog post that launched the whole concept of distros. And you can see here for what we're doing with our Lightstep distro, we actually use OpenTelemetry out of the box. So Lightstep speaks OTLP natively. You don't need to install any plugins to connect OpenTelemetry to Lightstep, but you do have to configure it. And so this is all the configuration you would have to do if you're doing it by hand. And it can be helpful to like go through this configuration. So first thing first, you have the Lightstep access token. You need this in order to gain access to your project. So that gets set as a gRPC header on the exporter. So you have to first put in your access token. We're secure. You got to create your TLS credentials. You got to get your certs. You have to set up the OTLP exporter. So again, this is core OpenTelemetry, but we're just creating our exporter with our headers and our security options, and we're configuring the default address to point at Lightstep. Then by default, we're going to add some resources that we've detected to your system. In particular, we care about service name and service version. And then we want to automatically add things like, language and library version and stuff like that. And then once you've got all of those pieces, you configure tracing by creating a new tracing provider with this config that we just set up. So we're adding our configuration, we're adding our exporter, we're adding our resources. And now you have a trace provider, and then you set that trace provider as the global trace provider. So this is, like, in my opinion, very well factored. Each one of these pieces makes sense, and it's a logical way to put them together. But holy smokes, you don't want to be like copy pasting all of this stuff everywhere. Like, that's obnoxious. And like, what if we end up tweaking some of these things, like telling everyone, oh, now go back and like tweak all of these copy pasta scripts everywhere. That's just kind of a gross way to do it. And given that all of this is boilerplate, once you've decided you're going to connect to Lightstep, it's a lot easier to just package that up in a little configurator. That makes it a lot simpler and makes it clear what kind of options you actually need to configure. But if you did this with the Lightstep launchers, you can also, nothing stops you from cracking open the lower level APIs and adding more exporters or mucking about with it, or configuring metrics a certain way. So that's why I say distros are more of just like a configuration layer. And so Amazon has basically done the same thing, but they've also included things like, their own ensuring a lockdown set of plugins that get installed automatically that have gone through their own security procedures and stuff like that. And we want to add a lot of that CI/CD to OpenTelemetry itself. So all of that auditing is happening in OpenTelemetry core, and then maybe some kind of GitHub action or trigger that can trigger builds of all these different distros. So that's kind of where we're going. I do, of course, have a worry that big co is going to big co, and maybe someone does something kind of gross with open source code. That's always a risk. You can look at, all of the different places where there's some contentious between what one of these infrastructure providers is doing versus maybe what the spirit of a particular project was. But in this case, I think Amazon is acting in very much in good faith. Alalita, I know, who's running the project, is pretty deeply involved in OpenTelemetry, and they've done a lot of work to actually help us set up our own CI/CD pipeline, and they're going to try to move a bunch of the work they've done back into core. So they are acting in good faith there. They just need to install some Amazon specific stuff just to make sure that getting started with them is easy. The same way getting started with Lightstep should be easy. So hopefully that answers your question, Daniel, and explains why it's not maybe as contentious as it looked when they first launched that. And that might be it. We've come up on 11:30. If anyone has any final question, I'm happy to answer it. Otherwise, I hope you enjoyed this workshop. I'm always looking for feedback. Again, you can DM me at Tetsuo on Twitter if you have any feedback, positive or negative. And if you have any questions, hit me up there. All right. Hope you enjoyed it.